Hey, this is Math 7, Unit 8, Lesson 1, called Mystery Bags. And we're going to be making some predictions today based upon things that we know. So the first thing says that Andre and his dad have been fishing for 2 hours. All right. In that time, they have caught 9 bluegills and 1 yellow perch. So they've caught a total of 10 fish altogether, right? 9 bluegills and 1 yellow perch. The next time Andre gets a bite, what kind of fish do you think it will be? So you want to be thinking about which one do you think he'll catch next. Will he be catching perhaps another bluegill, right, which is possible, or will he catch a yellow perch? So what we want you to do right now is we want you to think and write down which one do you think he would catch next and why do you think that's the case. All right, so give some thought to that and write that down. And if you need to pause, that's fine. Okay, I'm going to keep on going. So for me, as I think about it, I think, well, so far he's caught 9 of the bluegill and 1 of the yellow perch. As a result of that, my thinking would be most likely he's going to catch another bluegill because he's tended to catch more of those so far than anything else. So the next fish he's probably going to catch would be a bluegill. Now, do I know that for sure? For sure. Nope, I don't know that certainly. It's a possibility. It's most likely. Right? These are things we kind of say when we're predicting, that it's most likely that he would catch a bluegill next, but also that it's not certain. We don't know for sure because he could catch a yellow perch next, right? Or he could catch something else. Who knows, right? But most likely, based upon what has happened so far, he's going to catch a bluegill. And that's what we're doing today. We're talking about making predictions, but making what we call informed predictions, meaning that we have some information that allows us to make an educated guess, right? We have some information that allows us to make a guess, a prediction that is not 100% accurate, but most likely to be true. Okay? Now, the next activity here is one that I'm going to explain how to do, and I'm going to try to set one up to show you how this works if you're playing at home. It says your teacher's going to give you a bag of color blocks. Follow the instructions to play 1 round of the game. And basically, you're going to have 3 bags of blocks. Okay? One bag is going to be labeled green, another one is going to be blue, and another one is going to be red. Now, inside of the bags are going to be little Unifix cubes, right? With different colors, all different colors inside the bag. And we'll put them in there for you, and we'll shake them up. And the idea is that you and your group are going to write down the color that's on the bag in the first column of your table, which is right here on the next page. You can say what color bag you're looking at. So, I'm going to start mine off with the green, and then I'm going to use the blue bag, and then I'll use the red bag. And it's just me playing at home, so I don't have different people to play with here. Now, if you're playing at school, what they want you to do is, without looking in the bag, one person takes out one of the blocks, you show it to the group, and you record what that is. If you get the block that is the same color as the bag, then you get points. So let's say, for example, I look in the green bag and I pull out a green block. In round 1, I would get 1 point. Okay? During the rounds, the points will increase as the rounds go on, but that's really not what we're worried about too much of the points. It's more about, okay, are you able to make that match, right? We're looking more about matching than anything else. So as I do mine, I'm going to keep track of how many I'm getting that are the color that match the bag versus how many I'm not getting. Okay, so in my case here, what I'm going to do to change mine up just as I'm playing it on my own at home is I'm going to go ahead and each one I'm going to draw 10 times from each bag. Okay, and what I'm going to do just to kind of see what's going on here is I'm going to have this is the green bag. I'm going to make my thing, I'm going to keep a tally basically. So I'll keep a tally in this case of matches. So it matches, which means I would get a point, or not matches there. Okay? So that's what I'm going to do at home because that, again, it's just me, so I can't do that there. So I'm going to just reset my camera real quick and see if I can set up so I can play the game and you can watch me play the game. I'm going to do, for each one, I'm going to do 10 draws out of a green bag, 10 out of a blue, and 10 out of red, and just keep track of how many times I match that and how many times I don't. Okay? So let me reset real quick. Alright, so let's see how this works. So again, I'm going to use my green bag here. I'm going to use this chart, and I'm going to just put some tallies as I go along for how many times I get a match or how many times I don't get a match. So right now I'm looking at the green bag. So I'm going to reach in and see what I get. My first draw, I get a, looks like a white one, so that would be not a match. Put a little tally mark on my chart. Not. Pick it up, grab another one. Got a green. That's 2. Check it out. Another one. Got a green. So it's 2 to 1 so far. Again, just keeping track of my tallies. Mine looks something like this right now. So if you're playing along my way at home, there we go. There it is. I got 2 matches and 1 not match. So let's take it up to again. Got another green. So give that a tally. Check it out. Got a white. Put it back in there. Check it out. Got a green. Okay, so we've done 6 times so far. There's a white. Green. 2 more draws to go. Got another white. And a green. Alright. So for my scores here, I have a total of 6 matches for green and 4 not green. That's what I show so far for my first round with the green bag. Okay, so now I'm going to switch over to the blue bag and keep tally of those ones real quick. Put the green bag aside, get the blue bag out. If I'm looking for a match, I want a blue one to come up is my idea. So the first one is a yellow. Next one is a blue. It's 1 to 1. Next we have a blue, so it's 2 to 1. Blue, 3 to 1. Yellow, 3 to 2. Yellow, 3 to 3. Blue, 4 to 3. Blue, 5 to 3. Yellow, 5 to 4. Last draw. Blue. So 6 to 4 there as well. So we had 6 to 4, 6 matches for blue, and 4 not matches. So basically the same as the green that time, right? So, interesting. Alright, let's put the blue away and let's take a look at the red one. Trying to get red this time, so let's see what we get for 10 draws. We have purple. So 0 to 1. Purple. 0 to 2. Red. 1 to 2. Red. 2 to 2. Purple. 2 to 3. Purple. 2 to 4. Whoops. Red. 3 to 4. Purple. 3 to 5. Purple. 3 to 6. And last one. Red. 4 to 6. Alright, so 4 to 6. Okay, so we went ahead and we did 10 selections from the green bag, 10 from the blue, 10 from the red. And what we saw so far was that we had more greens than the other colors when we drew out of the green bag. We then had more blues than not blues when we drew out of the blue bag. Then we had not as many reds than the other color when we drew out of the red bag there. Okay, So it's interesting. It seemed to be that we had a little more matches, the greens and blues than the red, but not a huge difference just on how that worked out. 6 and 4, 6, 4, 4 and 6, pretty close to almost being like, you know, tossing a coin, a 50-50 chance, so to speak. But that's just kind of the way this one worked out, all right? So, again, however you play it, you might get different results because you would just draw something differently out of the bag. It's not always going to be the same. We're trying to make a prediction here based upon what we see. Okay, so that's just one way of looking at that there. So, if you had to make a prediction, or if you had to play a fourth round, let's say you played round 4. Okay, and I said you get to pick any bag you want, and you want to pick the bag that you think is going to have the most matches. Which bag would you choose? Would you choose the green bag, the blue bag, or the red bag? Well, most likely you would not choose this one, right? The red bag, most likely, it didn't come out very strong. I mean, granted it was close, but it seemed that it did lose. When you look at the green and blue, based upon our information here, if you want to make an informed decision, you could go either way. So I could see based on the data that I have, you might say green or you might say blue. And that's up to you. There's no real reason to pick one over the other based upon what you see in my chart, right? Again, your chart could have come out completely different. That's what's kind of fun about using data and making predictions and doing these things here. Okay, but what if I open up and show you what is inside of each bag? Okay, now we know the red one. We don't want the red one. It looks pretty poor. But here's what was in the red one. Ready? I'll dump that out there. When we dump the red one out, we see that there were only 4 red ones, and there were actually, look at this, there were 10 purples inside of that bag. So which one did you have a more likely chance of drawing? Purple. Now the fact that we ended up with 4 of the reds is pretty good, actually. we got lucky there, didn't we? I would have expected more purples than red, but that's just the way it works sometimes. So definitely you don't want to pick this bag if you're thinking, what's my best chance of getting a red? This would not be a very good bag to pick, right? You have more chances of losing than you do of winning. Let's look at another bag. Okay, now these ones, green and blue, they look to be about the same. Let's see what's in the blue bag. Okay, so in the blue bag we have yellows and blues. We have actually 1, 2, 3, 4, 5, 6, 7, 8. We have 8 blues. And look at this. We also have 8 yellows. So these are actually split, so you would expect it to be pretty even when you draw. Almost it would be a 50-50 chance, like flipping a coin, for whether you get a blue or a yellow. So are you likely to get a blue or more likely to get a yellow? Well, you're as likely as not, because it's going to come up one way or the other. It's going to be a blue or yellow and probably alternate back and forth most of the time. If you did this experiment 100 times, you'd probably end up with 50 blues and 50 yellows, or something pretty close to that, most likely. So again, is one more favorable or more likely? Not really, because these are the same number of cubes. Now let's take a look at the green bag. The green bag, we had 6 green and 4 the other ones, and we had the same with blue. So you're probably thinking it's probably about the same kind of ratio of green to not green. Let's take a look though. Check this out. This is where it gets to be kind of interesting. So here are 4, 5, 6, 7, 8, 9 green ones were in that bag compared to 3 white ones. Isn't that interesting? Yet we ended up with, drew 6 of these guys, and we had the whites come up 4 times. That is not what you would expect. We would expect to get more green than white, but it just happened that we ended up with more. We still had more green, but not as many as we'd expect. I would probably expect this if it was a normal kind of score. If you did this at home again, I would probably expect it something more like 7-3, kind of being the score there. This one should always be somewhere about 5-5, and the red one should probably come up with something like 2 to 8. If you had a score that would be kind of average. If I play this game again and again, those are more likely the scores I would expect to get. Unfortunately, I got these ones, but we did it live, and that's what it was. So hey, those are the results that you end up with. But that's just kind of the way it works. So sometimes it's helpful to know what's in the bag to know if you have a good shot at doing it or not. But we're just looking at what is most likely to occur. And that is really the focus of today's lesson. Okay? So one of the main ways that humans learn is by repeating experiments and observing the results, which is what we did. We made the experiment and we observed the results. If we want to learn, we repeat it to show something again and again, right? So babies learn that dropping their cup that makes it hit the floor with a loud noise by repeating this action over and over. Scientists learn about nature by observing the results of repeated experiments again and again. With enough data about the results of experiments, we can begin to predict what may happen if the experiment is repeated in the future. For example, a baseball player who has gotten a hit 33 out of 100 times at bat might be expected to get a hit about 33% of his time at bat in the future as well. In some cases, we can predict the chances of things happening based on our knowledge of the situation. For example, a coin should land heads up about 50% of the time due to the symmetry of the coin, 50-50. In other cases, there can be too many unknowns to predict the chances of things happening. For example, the chances of rain tomorrow are based on similar weather conditions we observed in the past. In these situations, we can experiment using past results to estimate chances. So, that's the idea. So that you're trying to figure out and predict based upon what you can see and observe, and that's what we did today. So I'm going to pause there and let you work on your homework in just a second, and then we'll come back and check it together. All right, homework time. It says Lynn is interested in how many of her classmates watch her favorite TV show. So she starts asking around at lunch, and she gets these responses, some yeses and some nos. In total, we can look at and count these up. It says in terms of yeses, she had 1, 2, 3, 4 yes votes. And for the no's, she had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 no's. So when we look at that chart, that's what that breaks down to. If she was to ask one more person randomly in the cafeteria, do you think they would say yes or no? All right, now the big thing here for you in your work is explain your reasoning. Looking at what I see here, most of the kids have said no, they don't watch her favorite TV show. So most likely we would say whoever she asked next would say no. We can't say that with certainty, just like we saw with the blocks in the bag, but most likely, based upon what we've seen so far, the trend is that no is going to be the next answer. Again, you want to write that down and explain that in your own words there. Number 2. An engineer tests the strength of a new material by seeing how much weight it can hold before breaking. Previous tests have held these weights in pounds. We have 1,200, 1,400, 1,300, 1,500, 950, 1,600, 1,100. Do you think that this material would be able to hold more than 1,000 pounds in the next test? Well, again, looking for explaining here. When I look over here, how many of them have held 1,000 plus pounds, 1,000 or more pounds? Well, it happened 1, 2, 3, 4, 5, 6 times. And how many times was it less than 1,000? Well, that was a whole 1 time. So most of the times that they're doing the experiment, it seems to be able to hold more than 1,000 pounds. So as a guess, a prediction, using an informed decision, we would say that, yep, the material will probably be able to hold more than 1,000 pounds the next time. It's most likely able to do that based upon what we've seen so far. Number 3. A company tests out 2 new products to make sure they last for more than a year. Product 1 had 950 out of 1,000 test times items last for more than a year. So that's pretty good. So out of 1,000, only 50 didn't work. Number 2, we had 150 out of 200 last for more than a year. So if you had to choose one of the 2 products to use for more than a year, which one's most likely to last? So it has the greater likelihood, the greater chance, or the greater probability, or all things we talk about. Well, looking at this here almost like a proportional relationship or a ratio here, when we look at the first one, you're talking about 950 out of 1,000. Okay, if we kind of think about reducing this a little bit, and I knocked off a 0, I'm talking about 95 out of 100 times. 95 out of 100 times is quite a bit, right? So it's going to happen if you thought about 95 out of 100. We've talked about before that 95 out of 100 is like a percentage. That's like 95% of the time it's going to work. Okay? If For the other one here, we have 150 out of 20. So if I did 150 out of 200, sorry, not 20, and drop that one off right there, I'm doing 15 out of 20, which reduces down to 3/4. Now 3/4 sounds like a pretty good likelihood, but 3/4 as a percentage is 75%. So the one that's the most likely, or more likely, is going to be the one that's up at 95% gonna last. This one is just a higher likelihood of happening. This one's pretty good, this one's just even better. And you can tell just by the approximating numbers. This is only 50 away from 1,000 out of 1,000. This is 50 away from 200 out of only 200. So this had 50 fails out of 1,000. This had 50 fails out of 200. So this one had far fewer fails. This had a lot more fails in terms of what it's starting with. So we definitely would say product 1 is your best choice there. Let's look at some review questions here. The next two review, prior learning. Number 4 says place these numbers in order from least to greatest. So you can use them as fractions, or you might want to put them in decimals. I went ahead and just converted all my fractions to decimals real quick so I can just compare them quickly. So I know that a half is the same as 0.50. I know that a third is a repeating decimal. It's like 0.333 forever and ever. I'm going to leave it there because I already have a 0.6 and 0.3. And 2/5 is the same as 0.40. So now I can use all the decimals and put them in order and then rewrite them as they are. So this is our smallest one at 0.3. Our next smallest is here, 0.33, which is really a third. The next largest, let's say, is 2/5, which is 0.4. Then I go to a half, which is 0.5, and finally end with 0.6. So now they're in order from least to greatest, just like that. All right, and finally number 5. Number 5 is a great question. It does take a bit of time here, just because it just has a lot of parts to it. It says a small staircase is made so that the horizontal piece of each step is 10 inches long. So the horizontal piece is this piece here. So this length right here is 10, that length is 10, that length is 10, and then over here this length is 10, this length is 10, and this length is 10. And 25 inches wide. So the width here is 25 inches all the way across, which makes this bar right here also 25. Each step is 5 inches above the previous one. So the height of this guy is 5, the height of this guy is 5, and the height of this guy is 5. What is the surface area? And with a staircase, it does want you to include both the two sides, the back side, the steps on the top and the front of the steps of each one, and the bottom side of the whole figure. Okay, so there's lots of things to figure out here. Now, one of the things you notice is that we know each step is a width of 10. So 10, 10, 10. When you add those up, that means the whole length of the stairs itself is going to be 30. This back side over here we already know is 25. Okay, and the height of the whole thing goes up by 5, 10, 15. So the height is 15. So at this point we have all the numbers in place. Now we have to make sure we keep track of all the different sides. So let's say we did the back of the staircase, which looks like this, at a height of 15 and a width of 25. So this piece right here. Well, 15 times 25 is going to be 375. So that piece is 375 square units. Great. All right, let's do the bottom piece, the base of it. Now the base of it, we see it's a 30 by 25, and 30 by 25, 30 times 25 is 750. Okay, so that's the flat part there and the whole bottom part. Let's do this actual side of the staircase. The side of the staircase looks something like this. Right? All right, so we have that there. We know this is 10, 10, and 10. We know the whole thing is 30. We have a 5, we have a 5, and a 5, and a 15. So what can you do here? Well, we could chop that up into smaller parts like so. So I could do 5 times 30 is 150. 5 times not 30, but in this case here 10, 20. 5 times 20, right? This length right here is 20. 5 times 20 is 100, and 5 times 10 is 50. So in total, I have 150, 150 plus 100 plus 50, which is going to be a whole 300, but I have two of those. I have the front side and the back side. So I'll multiply by 2, and I have 600. So there's that piece right there. So I have one piece, the back, I have the bottom, I have two sides. Okay. Now I need to get those steps. I have the top of the steps, which look like this, right? And they are 10 by 25. Well, 10 times 25 is 250. But how many steps are there? 1, 2, 3. So we do 250 times 3, and we have 750 for the top of the steps. But then we also have not just the top of the steps, but we have the front face of the steps. Right? We have that part right there. So that little front part, which is 5 feet, or 5 whatever inches tall, and 25 wide. So it's 25 times 5 for the front face, which happens to be 125. Now, there are how many of those? There are 3 of them. 1, 2, 3. So we multiply that by 3, 15, 6, 7, and 3. We have 375 for the front face. So those are all of the pieces, right? So all the pieces now need to combine to give us our total. So we're going to take the 375 from the back, the 750 from the bottom. We'll take the 2 side pieces, which is 600 altogether. We'll take the 3 top of the steps, which is 750, and the 3 front of the steps, which is 375, and we'll add those up. 5 plus 5 is 10, carry the 1. We have 7 plus 7 is 14, plus 10 is 24, plus 1 is 25, carry the 2. 7 and 3 is 10, 7 and 3 makes 10, which is 20. So 20 plus 8 is 28. So we have 2,850 square units becomes the surface area of that complicated shape. All right, that's it for today. Have a great day, and we will see you next time.